Hey everyone. So to solve an equation like this using logs, first we're going to simplify all of this stuff inside of bigger brackets under the square, and then we'll go into an exponential and finally solve for x, right? So let's start off with our first term that has a log in it. So we have 2 log base 4 of 2x squared being the argument of that log. Now, I'm going to use the power rule to bring the coefficient of 2 into the log as an exponent, and so we can write this equivalently as the log base 4 of 2x squared all squared, right? The coefficient becoming an exponent. And I'll do something similar to the second term. I'll have the log base 4, and we recognize that the 2 logs have a similar base, and we can apply the 3 as an exponent on 1 over x, like so. And the rest of our equation looks the same. Now let's go ahead and simplify down. So our equation becomes 3 times the log base 4 of 2x squared all squared. Reminding ourselves to square both the number and the x squared. So we have 2 squared being 4 and x squared being x to the 4. A square squared becomes 2 times 2, 4. So log base 4 of 4x to the 4 plus log base 4 of 1 over x all cubed is 1 cubed over x cubed, or simply 1 over x cubed, right? And we still have all of that inside a bigger bracket squared being equal to 12. Now we can use another log rule, recognizing that we have 2 logs with the same base, and through addition, we can combine the 2 logs into 1 by multiplying the 2 arguments, right? So we can now write, here I should do an equal sign here. I should just do an arrow point to the next line to be proper. So now we have the left-hand side of our equation looking like 3 times the log base 4 of, we're adding the 2 logs, and so we can combine them through multiplying the 2 arguments. And so that means 4x to the 4 times 1 over x cubed, right? And we're taking the log base 4 of all of this. Squared is equal to 12. If you write it a little bit differently, don't worry about it. I'm just being super thorough and super formal here so that it's very clear every step along the way. So now the left-hand side reads 3 log base 4 of 4x to the 4 times 1 over x cubed means 3 factors of x are going to cancel from the denominator and from the numerator once we multiply through, right? And so all we'll be left with is 4x times 1, or simply 4x, right? And we have that all squared. Now, and of course, that's equal to 12. Now we're getting down to the end of our solution. So let's isolate the 4x term over here. Let's get rid of the 3 up front by dividing both sides by 3, like so. So log base 4 of 4x all squared is equal to 4, right? Now we still have all of this inside of a square, as we always have. Let's get rid of that square by taking the square root of both sides to cancel out the square. And that will take us all the way over here. And so now we have our log base 4 of 4x being equal to the square root of 4, which we know we'll have to talk about the restrictions on our logs a little bit later on, but we know that the solution to the square root of 4 is positive or negative 2, so we'll have to consider both. So let's use positive 2 first, right? I'll make a note of that, option 1. So if we have that, then the log base 4 of 4x is equal to 2, and now remember how to transfer over from a log into an exponential. We do this by converting the base of the log into the base of the exponential, and so now we have 4x is equal to, the 4 pops underneath and becomes the base of the exponential rather than the log, and so we have 4 squared which means 4x is equal to 16, which means that x, of course, is equal to 4. Okay? Now, our second option, let's divide those so that it's clear. Our second option is if we take the solution of -2, right, for the square root of 4. Option 2 here. So if we have log base 4 of 4x being equal to -2, let's see if that turns out okay. Then of course, by the same argument, the base of the log can become the base of the exponential, and so we get that 4x is equal to 4 to the -2, right? With an exponent of -2, which means that 4x is equal to 1 over 16. And now dividing both sides by 4 garners the solution of x is equal to 1 over 64 for a second solution, okay? Now, maybe these are both good solutions. Maybe one of them is extraneous. Let's just see if either solution gives way to some stuff we're not able to evaluate. So let's take x equal to 4. If we have x equal to 4, and we have the log base 4 of 2 times 4 squared, which would mean 2 times 16, which would mean the log base 4 of 32. And we have the log base 4 of 1 over 4. No issues arise in this case, so that's perfectly fine. Our first solution is non-extraneous. It's a perfectly valid solution. Now, our second one, let's see if that gives rise to any issues. If x is 1 over 64, then over here we have 2 times 1 over 64 squared, which is totally fine. It's a small number, but it's still a positive real value, so no issues there. And here we have 1 over 64, which we know is simply 64, right? 1 over 64 is just 64 over 1. And so log base 4 of 64, that's perfectly fine. And so we have no extraneous solutions in this case. We always have to be mindful of any negative values popping up inside the arguments, because that would not, that would have our logs not be defined for those values. But in this case, both solutions provide real positive values inside our logs, and so no issues come up, and we're good to go. So I hope this helps. Thanks for watching. Take care.